According to section 210.19.3, the minimum size tap conductors for appliances are determined by their amp ratings. For appliances with a rating of 15 amps or less, a number 14 American Y gauge, or AUG, conductor is permitted. For appliances with a rating of more than 15 amps but not more than 25 amps, a number 12 AWG conductor is required. In this scenario, there is a small wall-mounted oven rated at 15 amps. Therefore, the tap conductor to this oven must be at least number 14 AWG. The counter-mounted cooking unit is rated at 25 amps, so it necessitates a number 12 AWG tap conductor. Therefore, the minimum size tap conductors are number 14 AWG for the oven and number 12 AWG for the cooktop. Understanding the National Electrical Code, or NEC, requirements for tap conductors is crucial for safe and compliant electrical installations. Tap conductors are used to connect electrical loads such as appliances to a branch circuit. The NEC specifies the minimum size of tap conductors based on the ampacity of the branch circuit and the rating of the connected load. Selecting the correct conductor size ensures that the conductors can safely carry the intended current without overheating, which can lead to insulation damage, fire hazards, or voltage drop issues. Firstly, understanding the branch circuit ampacity is critical. The branch circuit ampacity determines the maximum current that the circuit can safely carry. In this case, the branch circuit is rated for 50 amps. Secondly, determining the appliance ratings is necessary. The amp ratings of the appliances connected to the tap conductors must be known to determine the minimum allowable conductor size. Thirdly, referring to the NEC table 310.15 B16, this table provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the conductor's size, insulation type, and ambient temperature. This table is essential for selecting the appropriate conductor size for the tap conductors. The ampacity of the tap conductor must be sufficient to carry the load of the connected appliance. Fourthly, applying section 210.19.3, as previously mentioned, this section of the NEC specifically addresses tap conductors for ranges and cooking appliances. It outlines the permissible tap conductor sizes based on the appliance rating. For appliances rated 15 amps or less, number 14 AWG conductors are permitted. For appliances rated more than 15 amps but not more than 25 amps, number 12 AWG conductors are required. Fifthly, considering conductor dirting, it's important to consider conductor dirting factors. If the tap conductors are installed in conditions where the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, or if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be dirted according to the NEC tables. Dirting reduces the allowable ampacity of the conductor to ensure that it doesn't overheat. Sixthly, considering conductor termination ratings, the terminals of the appliances and the overcurrent protection device must be rated for the size of the conductors being used. Using conductors that are larger than the terminal rating can lead to loose connections, which can cause overheating and electrical failures. Seventhly, checking for local amendments. It's crucial to check for any local amendments to the NEC that may affect the requirements for tap conductors. Local jurisdictions may have additional requirements or restrictions that must be followed. Eighthly, using appropriate wiring methods. The tap conductors must be installed using approved wiring methods such as conduit, cable, or surface raceway. The wiring method must be appropriate for the environment and must protect the conductors from physical damage. Ninthly, ensuring proper overcurrent protection is vital. The tap conductors must be protected by an overcurrent protection device such as a circuit breaker or fuse that is sized appropriately for the ampacity of the conductors. The overcurrent protection device must protect the conductors from overloads and short circuits. Tenthly, documenting the installation. It's recommended to document the installation, including the conductor sizes, wiring methods, and overcurrent protection device rating. This documentation can be helpful for future maintenance and troubleshooting. Regarding the specific scenario, the 15 amp oven requires number 14 AWG conductors. According to table 310.15, B16. Number 14 AWG copper conductors with a 75°C insulation rating typically have an ampacity of 20 amps, which is sufficient for a 15 amp load. The 25 amp cooktop requires number 12 AWG conductors, again referring to table 310.15. B16. Number 12 AWG copper conductors with a 75°C insulation rating typically have an ampacity of 25 amps, which is sufficient for a 25 amp load. It's important to note that these ampacity values are based on specific conditions and may need to be dated depending on the installation environment. Additionally, it's crucial to consult the latest edition of the NEC and any applicable local codes to ensure compliance. In summary, determining the minimum size tap conductors involves understanding the branch circuit ampacity, the appliance ratings, NEC table 310.15. B16. Section 210.19.3 Conductor dating, conductor termination ratings, local amendments, appropriate wiring methods, proper overcurrent protection, and documentation. By following these steps, you can ensure a safe and compliant electrical installation. Additionally, it's crucial to understand the concept of voltage drop when selecting conductor sizes. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or even malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, several factors must be considered, including the conductor length, the conductor current, and the conductor resistance. There are various voltage drop calculators available online and in electrical engineering handbooks that can simplify this calculation. If the calculated voltage drop exceeds the recommended limits, the conductor size must be increased to reduce the resistance and minimize the voltage drop. In addition to voltage drop, it's also important to consider the conductor material. Copper and aluminum are the two most common conductor materials used in electrical wiring. Copper has a higher conductivity than aluminum, meaning that it offers less resistance to the flow of electricity. As a result, copper conductors are generally smaller and more efficient than aluminum conductors for the same ampacity. However, aluminum conductors are less expensive than copper conductors, making them a cost-effective option for some applications. When using aluminum conductors, it's important to use connectors and terminals that are specifically designed for aluminum. Aluminum forms an oxide layer on its surface that can increase resistance and lead to corrosion. Aluminum-rated connectors and terminals are designed to penetrate this oxide layer and provide a reliable electrical connection. Furthermore, it's crucial to properly torque all electrical connections. Loose connections can cause overheating, arcing, and even electrical fires. The NEC specifies the recommended torque values for various types of connectors and terminals. Using a calibrated torque wrench ensures that connections are tightened to the proper torque value. Regular inspections and maintenance of electrical systems can help to identify and correct potential problems before they lead to safety hazards. Visual inspections can reveal loose connections, damaged insulation, and other signs of wear and tear. Infrared thermography can be used to detect hot spots in electrical panels and wiring, indicating areas where connections are loose or overloaded. By addressing these issues promptly, you can prevent electrical failures and ensure the safety of your electrical system. When working with electricity, it's essential to follow all safety precautions. Always de-energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, or UL, the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It's important to be familiar with these standards and regulations to ensure that your electrical installations are safe and compliant. Continuous education and training are essential for electrical professionals. The electrical industry is constantly evolving, with new technologies and standards being introduced regularly. By staying up to date on the latest developments, you can ensure that you're providing your customers with the best possible service and that you're adhering to the highest standards of safety. There are numerous resources available for electrical professionals, including trade magazines, industry conferences, and online training courses. By taking advantage of these resources, you can enhance your knowledge and skills and advance your career. In conclusion, determining the minimum size tap conductors for cooking appliances is a critical aspect of electrical safety. By understanding the NEC requirements, considering voltage drop, conductor material, and following proper installation practices, you can ensure that your electrical installations are safe, compliant, and reliable. Continuous learning and adherence to safety precautions are essential for all electrical professionals.